Well, good afternoon, everybody, and welcome to the second part of the England annual meeting. And in this section, it's the chair's address. And it was Lynn Farrell who actually told me what I had to talk about. And so I'm going to be talking about how I became a botanist. So I'm going to take you on a voyage from North Wales to Cambridge and then visit parts of Antarctica. I've got a huge number of slides and I shall endeavour to race through them, perhaps not quite as quickly as I did for the AGM, but as quickly as possible so that you get to see a wide variety of different things. I'm going to start with my great-grandfather, who was a noted natural historian in the Llandudno area. And his particular specialism was marine animals, but he was also very interested in botany. And he kept a number of diaries in the period leading up to the Great War. And very often these diaries had pressed flowers in amongst them. What I wasn't aware of until quite recently was that he also had a collection of flowering plants that he'd collected in the neighborhood of Llandudno. And these included many species that had not been previously noted in that area. For example, this is the earliest record in Wales of this little plant, Cantunculus minimus, or chaffweed. He was also interested in polar exploration, and the diaries contain some cuttings from newspapers of the day showing events in the Antarctic. For example, this picture of the ship Endurance, which is being searched for at this minute in the Weddell Sea. Moving forward a bit, we come to my mother and father, who were both geologists, and Dad was employed by Sir Alfred McAlpine as a consultant geologist. And McAlpine's produced some really wonderful nature calendars, sadly not really involving plants, but with a wide variety of animals. Both my parents were members of the Liverpool Geological Society, and the society ran a number of excursions, and these were often to very out of the way places. And initially the bus company gave them the poshest buses that they had, but very quickly realized that an old, decrepit, well-used bus was much more suitable for going down some of the narrow country lanes, because otherwise the brand new bus invariably ended up with lots of scratches. And one of the places that I can remember visiting was the Hendra limestone quarry. And as a primary school pupil, certainly, and maybe only 6 or 7, I remember finding bee orchids at the quarry. And at that time, it was, I thought, relatively exciting, because that was before the real spread in orchids. Although reading the latest BSBI news and British and Irish botany, whether orchids are increasing as much, or at least these common orchids are increasing as much as I feel they are, is another matter. So I might have to do a bit more research as to whether orchids are increasing or not. Initially, my parents and I lived in a caravan, but then we moved to the outskirts of Wrexham, and one of the local features was Watts Dyke, which is a Iron Age fortification, presumably to stop the English getting into Wales or the Welsh getting into England. But it was a wonderful place to play in as children. And I went to Acton Park Primary School, And one of my memories from that time was the old smithy, where they still had a blacksmith shoeing horses. And there was the old duck pond, which was largely concreted over rather than being a true pond. But it was one of the things that stuck in my mind. But while at primary school, we had lots of things that involved nature. And I've still got some of the books of pressed flowers that we were told to collect at the time. So here's one of my, I think this is probably my earliest botanical record. Greater sea spury. My writing at that stage was not very neat. It probably still isn't terribly neat today. But my mother's writing, which is what you can see in the blue ink, was much better. And we had to write down where we found these things. So this was one of my better records because it says exactly what it is, when it was found, and where it was found. This one is rather less explicit as to where it was. It was found in a field. Well, there's quite a lot of possible fields where it might be found. So when I digitized these records, this one didn't get into the DDB. Mum, as I say, was a much better recorder of things in those days. And on a family visit to Holy Island at Witt in 1963, she collected many flowers. The chamomile doesn't seem to have been recorded from the island at all. And so this may have been a planted specimen in the castle grounds, which I vaguely remember visiting. And just looking at what the DDB has for me, these are the earliest records, and they cover quite a few places. And I seem to have made the first record for Erigeron carvinskianus in Ireland when I was aged 6, I think it would have been in those days. So obviously a very precocious botanist. On one of the visits to Ireland, in part we went there because Dad had geological work over there, but also it was a nice family holiday. And I remember staying at school where we milked the local cow by hand, which was quite fun, and helped the local baker with baking the bread for the village. But there seems to be an astonishingly large number of first records for the area. And I suspect all it means is that nobody else had done any recording there previously, hence the first records. Other resources that I made use of were cards from packets of tea, and Brook Bond in particular. You got a little card with every packet of tea, and these would usually run in different themes, and one was in wildflowers that could be found round and about. Another exciting natural history resource were the shell guides. Exactly how you got these, I can't remember, but they were certainly associated with shell petrol stations, and they were beautifully illustrated with a selection of the plants that you could see at different times of the year. Towards the end of my primary school days, I got a place at the King's School, Chester, initially in the junior school and in the senior school. And my parents moved to the old rectory in Doddleston near Chester. This is a recent picture. It was slightly less decrepit then than it is today. But Mum looked at the plants that grew locally, and in her books of flowers, these were an example. And the Trifolium micranthemum clearly grew in the grounds of the old rectory. But that was when lawns were cut with cylinder mowers. And today it's rotary mowers that very often leave all the debris behind. And that has clearly reduced the diversity of the lawns. Interestingly, however, it is surprising what will come up. And in May last year, my sister, who now owns the house, decided that the middle of this lawn would be left for No Mow May. And when I visited the next time, I was astonished to find that up in the middle of the lawn had come lots of flowering Stellaria graminea, lesser stitchwort. That lawn had been cut rigorously for at least 100 years, and yet the stitchwort was still able to grow and survive. So it does show you just how amazing plants can be. Some other flowers that my mother had recorded, including what she had put down as Melamparhum sylvaticum, but in fact, looking carefully at the pressed specimen, showed it was Melamparhum pratense, the common cowwheat, which she'd recorded on Hope Mountain, which is a nearby hill in Flintshire. And she'd also found Glebionus sagitum, which then was Chrysanthemum sagitum at Colesmere in Shropshire. And I was really pleased when I went back to Hope Mountain before the 2017 annual summer meeting to discover that the Melamparhum was still there and beautifully flowering. And locally at Trumpington Meadows near Cambridge, I was astonished to find at the edge of a cornfield a sustained patch of the corn marigold with some cornflower as well. That had originally come from some sown in wildflower mix, but it had clearly established itself in its rightful habitat at the edge of a cornfield. From King's School, I did my A levels and S levels and moved to Cambridge as a student, where I studied natural sciences, but that was mostly physical sciences, principally physics, with some geology thrown in as well. And also, while I was in Cambridge, my main interest was really bell ringing. And so I spent quite a large amount of time ringing church bells here and there. And also while I was there, I did join the Cambridge Natural History Society, but that wasn't really for the botanical interest. That was for the geological interest, because in those days they had a geological section and they went on field trips to various parts of the county. So this was one trip to Home Fen, and those iron posts show how much the peat has shrunk since they were first put in. When those posts were installed, they were hammered in until they were level with the ground surface. And since then, the ground has dropped away. Having graduated and done a one-year teacher training course, I applied for a job at the British Antarctic Survey in Cambridge and was lucky enough to get it. And in those days, only the right-hand half of this image had been built. And there was no canteen on site. So if I wanted a hot meal for lunch, I had to walk to the Cavendish, which was only a bit less than a kilometre away, so a fairly short walk. But on occasion, I would try and count the number of flowering plants that I could see, mostly dead common ones, like these, which were fairly easily recognisable. And at some point, I think I must have started to make a list. And clearly, I got up to about 50 different species that I'd managed to see on these walks, which I thought was doing quite well. And at that time, although I'd only really got a passing interest in botany, I used some of the colour picture books and these were two of the ones that I still have. Now, each year the Society held a conversazione, or annual exhibition, and because I was a member of the Society over many years, when they appealed for more exhibits on one occasion, I thought, well, I'm just working on ozone data from the Antarctic, and I'll show people at the exhibit what it's all about. And that led to something else, but I'm going to use this as a little digression to head towards Antarctica for the first time and tell you a little bit about the Antarctic ozone hole. Now, ozone is a form of oxygen. The air that we breathe, the oxygen has 2 atoms to it. Ozone has 3, which makes it much more reactive. And like with many scientific discoveries, it was an accident. This Swiss-German chemist was experimenting passing an electric current through water, knowing that he expected to make hydrogen and oxygen, but he noticed a funny smell and followed it up and found that he'd made ozone. That funny smell is the same sort of smell you get at the seaside, but at the seaside, the smell comes from rotting seaweed rather than from ozone, although everybody says it's good to go to the seaside to get a dose of ozone. The next step in the discovery of the ozone layer came from astronomers who were looking at the spectra of stars, and they found that there was a cutoff in the ultraviolet and deduced that there must be something in the atmosphere that was blocking the ultraviolet light, and that was ozone. And in the 1920s, a professor of engineering at Oxford University devised the instrument that is still one of the world standards, the Dobson ozone spectrophotometer. And there is me in the Antarctic making use of it. And really one of my first jobs with the survey was to analyze some of the ozone data coming back. And after a little bit of hard work, I noticed that each year values seem to be getting lower. And in conjunction with my 2 bosses, this paper appeared in Nature, announcing to an unexpected world that ozone values over Antarctica were declining, and that this was probably linked to increasing amounts of chlorofluorocarbon in the atmosphere. Since then, the ozone decline hit a rock bottom, and in recent years has started to recover. And that's largely thanks to the Montreal Protocol, which has prohibited the release of ozone depleting gases into the atmosphere. And that recovery is just about statistically significant today. And this just is a video showing this year's forming ozone hole. And you can see it's forming over Antarctica as the spring develops. It's largest in the end of September, early October. And then by the summer, it's pretty much filled in until the cycle starts again. So it's very much an annual cycle. And it's caused by the fact that the ozone layer during the winter cools to such low temperatures that clouds can form in the center of the ozone layer. And on the surface of those clouds, chemistry takes place that converts the chlorine from the CFCs into an active form, which when combined with sunlight leads to the destruction of ozone. And as we speak, that process is going on over the Arctic. This year, we've got one of the larger circumpolar vortices on record, and those clouds have formed over the Arctic. And although this doesn't quite qualify as an ozone hole, it is bringing us effects. And it's probably due to the stability of the polar vortex that we've had the big storms recently. And possibly when it breaks down, we'll see the effects in another beast from the east. But that remains to be seen. Despite the protocol, we still need to keep monitoring. and ground-based measurements of the amount of CFCs in the atmosphere showed an unexpected increase in the expected rate of decline, so that things weren't declining as fast as they should have done. And this was traced to factories in China producing the gas to be used as a blowing agent for insulating foam. So this is still something that is very much in progress, and where we have probably another 40 years or so of ozone holes to come. But going back to the conversazione, having put up an exhibit at the meeting, I thought it would be interesting for people. I thought it would be worthwhile going to the Society's annual general meeting, which was held during the exhibition. And they said, oh, membership numbers are declining. We need to try and get younger members in. And I said, well, why don't you have a web page? He said, ooh, that's a good idea. Sounds like you know what you're talking about. Could you create one for us? So I said, okay, yeah, I'll put something together. And then the next year they said, Jonathan, we think we could do with a younger president. Would you be willing to be our president for a term of office? And I said, well, I don't really know anything about natural history. I'm a physicist. And they said, no, that doesn't matter. I'm sure you'll be a wonderful president. So I took up the role, and I thought so I'll just backtrack. The Society's exhibitions still continue. And some of the more recent ones, I've advertised our local Flora group and some of the plants that grow in Cambridgeshire, as well as still promoting the Antarctic ozone hole and the latest science there. But just backtracking to my thoughts as president, one thing was that I thought I needed to learn a bit more about natural history. So I went on a few of the excursions that they'd visited, to places that they'd visited. And one of them was with a noted local botanist, that's Max Walters, who you can see in the foreground. And he was a very inspiring person. And one of the things he explained to me was that really, even though you're a beginner, you need to start learning the Latin names of plants. And if you do so, if you should go somewhere else where English isn't the native language, you can still speak the language of the plants, because they will know the Latin names and you'll know the Latin names, and you can exchange ideas. And I thought that was a really inspiring reason why you should learn the Latin names of plants, because you can speak to people about plants without necessarily knowing the local name for them. And what I thought Society might do, because they had relatively few outside events then, was to walk the footpath where I'd been making my lists from, that was on the route between the Antarctic Survey and the Cavendish Laboratory. And we'd make a note of when species came into flower. And this is phenology. And so it linked in with the climate change measurements that we were taking in the Antarctic. So that was sort of how we started. But the footpath did have one very interesting plant that grew along it. This is the yellow vetchling, the Thyrosophaka. And this was one of its relatively few locations in Cambridge. Since then, the management of the area has really been inappropriate for it, and the plant is no longer to be found there, but it's quite likely that it's still in the seed bank. But some way into the project, I discovered that the Botanical Society of the British Isles was conducting its local change project, and that it just so happened that the area that I'd selected for these local walks was one of the tetrads that the BSBI was looking at for local change. So that slightly began to change the emphasis from phenology to actually recording plant species. And initially we started just doing this at the tetrad level. And during the project period, 344 species were recorded. But since then, the total is now one of the higher ones for a tetrad in the country. And in part, it's because this is on that boundary between urban and agricultural. There's been a lot of habitat change during the period. And moreover, a botanist has been working in the area and has been able to spot things during breaks and so on. But of course, the local change project led to the publication of this book, and hopefully we'll be doing a repeat of it perhaps in 2024. That remains to be seen. I then eventually went on and have become the BSBI Vice County Recorder for Cambridgeshire. But I'm still learning, and it's very important that we all do keep learning. So here was on a field trip last year where we had Brian Evesham teaching us all about elm trees. And in this picture, you can also see two of my other mentors with their backs to us. On the left here, Alan Leslie, and just in front of him, Charles Turner. Without their support, I really wouldn't be where I am today. And so I try and pass on what I've learned to in this case, it's our local Flora group, but hopefully in the future, it'll be our local Flora network. And this is at a visit to the Cambridgeshire seaside, or what passes for the Cambridgeshire seaside, up in the north of the county. And there we're admiring wild celery, Apium graveolens. So I'm now going to take you off to Antarctica and see a little bit of the sites and flora of that part of the world. So I used to work in the British Antarctic Territory, this pie-shaped slice of Antarctica running from the pole to 60 south. But I've also visited the Falklands and South Georgia during my visits, and I'll show you a little bit of all of those. Most recent trip was to Halley Station, and that's on a floating ice shelf. And one of the things that this drives home to me is that you need water for life. Here, the temperature very rarely gets above freezing. And so all the water is locked up as snow as ice. And there are really no living things in the area whatsoever. And the reason I went there was because this crevasse that you can see me leaning over to get a good look at was opening up and threatening to block all supply routes to the station. And so I was employed to go down out of retirement to become a weather observer, which is what I'd previously been training people to do. So I was well qualified to do it. A lot of the weather observations are done by automated equipment these days. But when you've got aircraft flying, you need to know what the local weather itself is. So that's the clouds and their heights, whether it's snowing, what type of snow, whether it's foggy or not. And so all those observations had to be passed on to our aircraft. You also got to do fun things like launching the weather balloons. These go up to heights of 20 or so kilometers, measuring pressure, temperature, and humidity and winds as they go up, and also making the ozone measurements with the instrument. And I was able to do some quite useful calibration work on this instrument, which was in the process of being automated. There's also time for a bit of fun. And so one of the things we would do is go skijuring in the evening. This is equivalent to downhill skiing on the flat, and you're towed behind a skidoo or snowmobile to get a little bit of speed up. And as I'd learned to ski in the Alps, my style isn't too horrendous. But most of my visits really started in the Falklands, at Stanley. And even on my early visits, before I became interested in botany again, I was quite interested in the plants that grew there. So these are some of my early pictures. I think this is probably from 1981, and a local bay with lots of that yellow flower, which is actually gorse, which is an alien species there, but which had been used to make animal stockades, but which has escaped and liked the area. There are plenty of species there that are really not familiar at all. And I'm just going to show you a few of the pictures of them. So there are various orchid species. This is a plant from a family that potentially does grow in the UK, but a different genus. This is a really pretty little plant, really lovely little flowers. Their native pimpernel, the Anagallis alternifolia, which I suppose is now changed to Lysimachia alternifolia, is slightly similar to the bog pimpernel that we have, the Anagallis tenella, at least in terms of flower color. They have a native strawberry, but in fact, as you can see from the Latin name, it's actually rubus, but it is really, really tasty. And it's a great delight to try and find these plants, which used to grow in what they call stone runs, which are glacial features where larger blocks of stone have been segregated into runs down the hillsides. Other plants that I've seen, this on a more recent visit, was a member of the Botanical family. This is native to the Falkland Islands, and also their endemic lady slipper orchid. Now, this was the first lady slipper orchid I had seen, and this is, I think, again from probably 1981. And I'd assumed that the British lady slipper orchid was broadly similar, and I was quite astonished when I saw it at Malham Tarn, at least vegetatively, to find out how much a bigger plant the British one was. There are other sort of semi-familiar plants, such as the tall fern, which is similar to our hard fern, the Blacknum spicant. There are also some species that we're very familiar with, and so these have probably been brought in accidentally with animal fodder. So, for example, Stellara graminia, which I mentioned previously, grows in the Falklands, and so does Veronica officinalis, the heath speedwell. But I did find it, or have found a few new plants for the Falklands, and this was one that I found on a roadside. And the expert in the Falkland Flora told me, "Oh no, you must be mistaken. It's a different species." But I was fairly certain. And on a subsequent visit, I took a picture, and he then agreed with me as to exactly what it was. This was another one where the local people knew all about it because they made watercress soup from it, but which had never managed to be reported. Here it's an escape from the facility that you can just see at the top of the screen, which was a local market garden where they grew the plant, but it had escaped and was filling this little channel. Moving a bit eastward towards Bird Island, towards South Georgia, Bass has two stations there, Bird Island on the western tip and King Edward Point on the north side of the island. And again, my visits there have been purely to look at the weather recording equipment, which largely runs automatically. Grytviken, or King Edward Cove, has a relatively mild maritime climate, so temperatures above freezing during the summer and only just below freezing during the winter. Bird Island, that bit further to the west, is slightly more isolated, and this is looking down on the station, and you can see that it looks a pretty bleak place to have a base. In the nice days, it can be very pleasant, and here we are picnicking on the grass, I think amongst the Echina magellanica, which at that stage wasn't a problem because it was still in flower. You get really great views of the night sky. There's no light pollution there because at that time we switched off the generators at night and had no power whatsoever. So it was absolutely dark. And there's the local inhabitants. The young fur seals are quite cute, but they will still be aggressively territorial and go for your ankles. And you are living in the middle of this seal colony, and you can definitely very much see nature in the raw, with scavenging birds pecking away at the carcasses of some of the seals that didn't survive the breeding season. But on the other hand, you do get the delight of seeing wandering albatross chicks just hatching out of the egg. And that was really one of the great thrills that I had of visiting the place. One of the other things that I got to do, which a physicist doesn't normally get to do, was help some of the biological researchers with their work. And one of the things they were looking at was the macaroni penguin. And these go out to sea to feed and then come in. And the first thing you had to do when you were looking at what they had eaten was to catch them, and then you put them in a straitjacket, and then you poured a little bit of warmish seawater down their throat, hold them upside down over a bucket, and then they regurgitate the stomach contents into the bucket. And you can then find out whether they've been eating squid or krill. And that was quite an experience. The other thing I did at this place was to find a new plant for the island, one of those very common ones that most botanists can recognize, annual meadowgrass perennia, but it had never been seen there previously. And then I spent some time at Grytviken, King Edward Point, which nestles on a little promontory below this big mountain. By and large, the place is much greener than other areas. Grytviken is the abandoned whaling station. It was abandoned in the 1960s because the whalers used up all the resource of the whales, and they just wasn't profitable anymore. But the whalers brought with them some native species from here. So yarrow grows, as does cow parsley, and sheep sorrel. And those are probably species that are now firm denizens. This little plant is a native in the Falklands, but thought to be alien in South Georgia. But it didn't seem to me that it was doing much harm if it's only doubled in size in 40 odd years. There are some species that are both local to the island and local to us. So Chrystopterus fragilis is one that many of you will be familiar with. There are other species that are less familiar, but are present in the UK as different members of the genus. Here we've got Hymenophyllum, but Hymenophyllum falklandicum. Within the foreground, the much greener, lesser prickly burr, the Echina tenera. And up until very recently, a completely unfamiliar fern taxa for the UK, but which has been found now in Ireland. Not this particular species, but strap fern is now known from Great Britain and Ireland. And this is the larger prickly burr, and it has those little Velcro hooks on it, which those of you that are familiar with the Echina novazelandica will realize that once they're into your socks, they don't come out very easily. And then the two local species have hybridized to produce a plant that's endemic to South Georgia. And this is a specimen in the herbarium at the British Antarctic Survey. The native bedstraw for the island has a really lovely vanilla-like smell, and you could detect that the plant was there by smell before you actually saw it visually. And again, here I found another new species for the island, one that's common to many beginner botanists. This is Cocksfoot Dactylis glomerata, virtually ubiquitous in the UK. And here it had almost certainly been brought in by contractors. Now, in this part of the world, they are extremely xenophobic. They do not like non-native species at all. And when a species of bittercress was found, it was assumed that the British bittercress, Cardamine hirsuta, it must be eradicated instantly. And so you can see in that bottom picture that they've sprayed the area with Roundup. Now that, I suspect, has probably done more damage to the ecology of the place than the bittercress ever would, particularly as it turned out that it wasn't Cardamine hirsuta and was most likely Cardamine glacialis, although it couldn't be 100% certain that that's what it was. Now, the problem is that Cardamine glacialis is native in a number of South Atlantic islands. And although it had never previously been seen on South Georgia, there does remain the possibility that it might have been native there. Moving a bit further south towards our Rothera station on the Antarctic Peninsula, that is reached either by ship or you can fly into this gravel runway. And here temperatures are rather cooler. The summer temperatures get just above freezing, so you do have liquid water, but winter temperatures average out at about -10 with a bit of spread. And in Antarctica itself, there are only two native species of flowering plant. One is a grass, Dischampsia antarctica, a relative of the Dischampsias that we have in the UK, but generally a much smaller, wirier plant. And the other is little pearlwort. It was called then Colobanthus catensis. I have a feeling it may have changed its name more recently. And that's a cushion-forming plant which survives by forming these cushions. And where you get suitable habitat, both species can be quite widespread. And in the background, or sorry, in the foreground really, you can see there the slope of a north-facing mountain. And because it's north-facing, that's the sunny side. And so there's a lot of meltwater rushing down. And on the plateau at the base, you actually get lawns comprising the Colobanthus and the Dischampsia. So it can be relatively lush. You can also see one of the other native species there, the skuas, which can dive bomb you if you get too close to the nest site, but also the beautiful scenery of the area with glaciers tumbling down to the sea. A number of parts of Antarctica are at risk of alien species establishing, particularly the northern part of the Antarctic Peninsula. And there a couple of species have been found established, although these aren't pictures from that area. One is an everlasting Gammakita species, which doesn't have, as far as I'm aware, a common name. And the other one, which has this magnificent name of hairy chocolate flower, Salvia magellanica. I've not yet been able to discover why it's called the hairy chocolate flower, and it does seem to have rather nettle-like leaves. Now, whether we should aim to keep Antarctica in isolation and never let any new species appear there, I don't know. I think my feeling is that with climate change a fact, we cannot really afford to wrap these areas in plastic bubbles that don't allow evolution to take place. And that neatly brings me on to the subject of climate change. And it's interesting that climate generally varies in regional patterns. And so the area of the Antarctic Peninsula, South Georgia, the South Sandwich Islands and the Falkland Islands has a broadly similar pattern of cooling until the 1920s, and then with warming subsequently, and perhaps a bit of a standstill over the last couple of decades. What we do know from ice cores is that the amount of carbon dioxide in the atmosphere has changed substantially between glacial periods and interglacial periods. And from flask measurements, it has gone up substantially since the last interglacial period. And there are two key things about this graph. One is the difference in carbon dioxide between a glacial period and an interglacial period is roughly the same difference as between an interglacial period and today. And that corresponds to a difference of roughly 8 to 10 degrees in temperature. And although we talk about temperature rises being limited to 1.5 or 2 degrees by the end of this century, nobody is talking about what the limits would be at the end of the next century or the century after that. And the end of this century is not going to be the steady state. There will be longer term rises than that. The other key thing about this is the rate of change. Nature, in coming out of the last ice age, took 1,000 years to do what we're doing in 13 years. And this means that nature is not going to be able to keep up with the changes that we're imposing upon it. We can see some of the effects in Antarctica. The vast majority of glaciers along the Antarctic Peninsula are in retreat. There are some that are in advance, but an advancing glacier is not necessarily a healthy one, because the glacier motion is a very complicated function of precipitation and temperature. And so if the bed of the glacier gets greater lubrication in a warmer world, it may actually advance. I should also say that, having mentioned that there are regional patterns, not all of the Antarctic has warmed, and at our Halley station, broadly speaking, there has been no change to the mean temperature over the last 60 or so years, although there may be long-term swings about the mean in temperature. This is the most recent global picture. We can see at a glance that most of the world is warmer than average. The only bits that really are not are parts of the Pacific on the west side of the Americas. And that is a consequence of the El Nino La Nina oscillation. And that is actually what's currently holding up the rapid rise in temperature. But overall, our climate is a very complex system. The ozone hole interacts with winds to change the climate. Changing climate interacts with the ozone hole to strengthen it. Volcanoes will play a part, although very often they are short-lived effects. And what we are putting into the atmosphere makes changes as well. And my view is that until we can be 100% certain of the consequences of what we're doing, we should take the precautionary principle and not put substances into the atmosphere unnecessarily. And at the moment, despite the warning of scientists, the politicians are really doing not much more than talk. I fear that at some point they will get a rude awakening. But I do not think we will ever get back to the conditions that existed 120 million years ago on the Antarctic Peninsula, where there was this wonderful Cretaceous forest of ginkgo, araucaria, and various tree ferns. And if you look really carefully at this image, you can spot a small dinosaur in the background. So that concludes my address. I hope I've enthused you as to how I became a botanist, and also some of the things that that career has enabled me to do.